So a man who's 6 feet tall walks away at a rate of 6 feet per second away from a light. So we have a light that's shining, and here's this guy who's 6 feet tall, and the light is 15 feet tall. So we want to find the rate at the length the shadow is changing. So we want to find the rate of this. So I'm going to call this x. So this is going to be y. And y is the rate of change of the man. So the rate of change of the man is 5 feet per second. And we want to know what his rate of change is when he is 10 feet away from the base of the light, or the rate of change of the length of the shadow. So I'm going to do similar triangles. So notice I have this big triangle and a small triangle. So I'm going to do proportions. So I'm going to do 15 is to 6 as x plus y is 2x. I'm going to cross multiply. Subtract 6x from both sides. And then I'm going to solve for x. Okay, so I'm going to go ahead and take the derivative of this. So the derivative of x is equal to 2/3 dy. So notice that it doesn't matter that he's 10 feet away from the base. The rate of change of his shadow is always going to be just dependent on how fast the guy's walking. So this is going to be 2/3 times how fast he's walking, which is 5. So that's going to give me 15. Do that again. That's going to give me 10/3. And his units are 10/3 feet per second. Part B asks, at what rate is the tip of his shadow moving? So now we're looking for the tip of his shadow. And the tip of his shadow goes from y to x. So what we're going to do is, once again, we're going to do a trick. We're going to call it t, and t is going to be x plus y, the tip of his shadow. So as we use the formula that we originally used, we're just going to go 15 over 6 is equal to t over x. So we're going to cross multiply, and we're going to solve for t, because that's what we're trying to find. So t is going to be 5/2. So if we take the derivative of the tip so we can find the rate of change, the rate of change of the tip of the shadow only depends on the rate of change of the length of the shadow. And we already found the length of the shadow in part A, which is 10/3. So we're going to substitute that in. And we're going to get 50 over 6, which is 25 over 3 feet per second.